All right, so as we start this, I wanted to call our attention back and remind us of the first mechanism that we built, which was high gearing. In high gearing, we took the torque of the motor and traded it in for speed because we have a gear that's big turning a small gear, 36 teeth per rotation, turns this, which is 12 teeth, which means to keep up, this has to spin 3 times every time this spins once, which makes it go much faster. You can see also I've changed the flags out for these little wire things. These are better because they're smaller and they won't run into each other. All right, what we're going to do today is we're going to move this output shaft over here by using an idler gear in between. Notice also today, an important thing to remember is that these spin opposite of each other. So if this one is spinning counterclockwise, this one spins clockwise, and vice versa. If this one spins clockwise, this one spins counterclockwise. That's going to change. We're going to change that today with our idler gear setup. Okay, so let's take a look at what we're going to need for this. I'm going to take this apart because I'm not going to assume you have it put together. All right, so here's what we're going to need for this one. We're going to need these 2 gears, so 2 of these. We're going to need one of the small ones. So the 36 tooth, we need 2 of those and 1 of the 12 tooth. I've got 3 motor shafts. These are all 9, but you could have them longer than that. Maybe able to get away with shorter, I don't know. And then I have 3 of these spacers to hold things together so that the shafts can't slide out. And then I have 3 things, doesn't matter what, that I'm going to use for turn indicator so I can watch the gears turning. All right, so first of all, let's install the very first gear. First, we need to put this in the middle. So remember, it's 3 down and 3 over. And the spacer in the middle goes in there. And if you slide it out this way, now this can't slide out of there. Okay, good. We're good to go with that. And we need to put on our first gear. So let's take a 36 tooth gear. And I'll just use one of these very large, the large flag there. So we got that installed. That looks pretty good. Turn that off. Okay, and the next thing, I'm going to put this one here, put a flag on it, and put that in. Now this one's, this one's a little bit different. For this one, we're going to mesh it down here. So not straight down. We're going to go down a couple holes and over a few. Right there. So if you look, if you count down from the shaft, it's 1, 2, 3, 4 down, 1, 2 over. And it should mesh. If they don't mesh, you don't have it right. But these do mesh. All right? So take a look at that. And if you drop it in and it doesn't mesh or it doesn't fit in, you know you've done it wrong. All right. And then we need a spacer on the back to hold it together so it doesn't fall out of there. There we go. Finally, this was the output shaft that we wanted, so I'm going to slide on the 12 tooth small gear right there. And then I'm going to put this one, see where this shaft is? We're going to go straight over from there, just like we did on the original one. And then down here. So look what we've done. We've moved it, and make sure they mesh, right? There we go. Yeah, they're all put together. If it spins around, then it didn't mesh. All right, so let's take a look at this and what this is going to do for us. Now remember, when we started, these 2 gears were turning in opposite directions because they were next to each other. That's not true anymore. Watch what happens here. We still get that speedy 3-to-1 speed up. So you're going to notice the output still spins 3 times as fast as the motor. Yep, 3 times as fast. So if you look at that, we have 3 times as fast right here. One thing you do notice, though, is now that these are both spinning. This one, so the motor and the output shaft, they're both spinning in the same direction where they used to be opposite directions. Let's take a look. Yep. You can see they're both spinning counterclockwise, or they're both spinning clockwise. All right, so why is that? Well, let's take a look at what happens. This one, so it goes clockwise, counterclockwise, and then from counterclockwise, it switches back to clockwise. So we started on clockwise and ended on clockwise. So that's one thing. Another thing is notice it moved from here, which was close to this gear, and the output shaft got moved down here because now we have this thing kind of transmitting power in the middle of it. So a couple of things there that we saw that we've changed. Also, you can see idler gears. The problem with them too is they're going to take up a lot of room. They're complex. We had to add a whole extra shaft in between there for basically the same output, although it is going in an opposite direction, so that does matter. And we can see having an extra gear in between here, whether it was big or small or whatever, doesn't change the final gear ratio. The gear ratio would still be calculated completely, absolutely, simply because there's an idler gear that doesn't change that. All it does is we would still calculate it as 36 divided by 12. So in the end, that didn't change at all. So when you're done, come and show me this.